OW3 workers, some changes that are in 10.01. So just as an introduction, the workers that we've added are a JavaScript worker, which will allow you to execute JavaScript code running in Node.js. That's something Klaus is going to be talking about in another session. POP3 worker, give you POP3 mail access in a worker. Crypto, which is encryption, data encryption. Hash, which is hashing. And then we've enhanced the FTP worker to include SMTP support. Anyone wondering why, for example, the JavaScript worker is in OW3? It's because we use curl to communicate between OW3 and Node.js, and OW3 already contained curl. As I say, the JavaScript worker is something Klaus will talk about in a separate session, but it will allow you to execute any JavaScript pretty much you want running in Node.js. So you've got a nice interface between Omnis and open source Node.js modules, of which there are thousands. The only thing to be wary of if you're using any of those in your application is the license. Most of them have got a nice license like MIT, but occasionally there's one that really isn't very compatible with using it for free. I'll just touch on the POP3 worker. This will allow you to asynchronously download messages from a POP3 server. When you receive the message through the worker completion method, the message body will be structured in a similar way to the way the message body is structured when you use the old POP3 web commands. So if you've got code that's already using those commands, the way you deal with the message body is at least compatible with that. So you'll receive a list representing the mine content. We'll talk about SMTP. So just to clarify, because this always seems to cause problems in support, SMTP is not the same thing as FTPS. So FTPS is when you're running FTP over a TLS connection, whereas SMTP is a completely different file transfer protocol. It runs over an SSH, a secure shell connection. So the worker, when you're using it with FTP, is similar to when you use it with FTP or FTPS, but there are a few differences that you've got to be aware of. One is you've got to explicitly specify the character set with which you're working if you're using character data. So there's no sort of allowance in the SMTP protocol for negotiating a character set with the client, so you just have to know. The append file action is not supported. And then if you're using the execute action to execute any sort of FTP commands that aren't supported through any of the other mechanisms in the worker, well, you've got to be careful because the commands that you can use with SFTP are different to those that you can use with FTP. There's some commonality, but there's quite a lot of difference as well. And then the other thing you need to look out for is that there's a lot of new properties, methods and constants that you need to set up the SSH connection, so you need to look at those. But primarily in this talk I'm going to be talking about the encryption worker in more detail and the hash worker. So crypto is the OW3 encryption worker, and just as a bit of background, we support these four methods of encryption and decryption: AES, Blowfish, Chameleon and DES. The reason for that is because they are included in Embed TLS. Embed TLS is part of the OW3 external component because it's needed by libSSH2, and libSSH2 is there because we needed it for SFTP. So a lot of this comes from having included Embed TLS to support SFTP. So these are the commonly used encryption algorithms anyway that are included in Embed TLS. And as I say, you can use this worker to asynchronously encrypt and decrypt data. So just some concepts to be talking about. So encryption algorithms generally work with a fixed size block of data, and certainly in the case of OW3 this is what happens. So it's typically a 64 or 128-bit block of data that it can encrypt individually, and obviously it will then do that multiple times to encrypt a larger block of data. But then you have what's called a cipher mode, and that actually indicates how the encryption algorithm is applied to encrypt data of any size. And obviously if you're given some encrypted data, you need to know not just the encryption algorithm was used, but also the cipher mode, because that affects how the encryption algorithm is applied. So we support 3 cipher modes, which are electronic codebook, cipher block chaining, and counter. And I'll talk about those in more detail a little bit later. So another concept is something called an initialization vector, which this is some random data, and you feed it into the encryption algorithm to make the result of encrypting the same data with the same key different each time. So it's another way of providing a bit more security to encryption. And also padding. Unless you're using the counter mode, I think it's a counter mode, some of the cipher modes will only work with using an exact multiple of the block size. So that means if you've encrypted some data and you want to be able to decrypt that data, and it's of some random length, you need to be able to pad the data up to the correct block size. And what this will mean is the output data length will always be greater than the input data length, because even if you've got an exact multiple of the block size, you still need to apply padding to know that there is padding. Otherwise you could be misinterpreting the data at the end of the block as padding when it's not. So there are 4 types of padding supported by the worker, and this is because there are quite a few different types of padding in use for various reasons in the outside world. Obviously, if you decrypt some data, it's another thing you need to know when you're decrypting data. You need to know what sort of padding was used if you've been given a type that requires padding. Otherwise, you won't be able to properly decrypt the data. So we have PKCS7, where at the end of the block you'll get n bytes of value n. You're padding with n bytes. 1 and 0s, so you'll pad with a byte with hex 80, followed by n minus 1 bytes, which are 0. Another one where you'll pad with n minus 1 0 bytes followed by a byte with value n. And then the last one is you'll pad with n bytes, where n is the number of padding bytes. N 0 bytes, where n is the number of padding bytes. So these are just different techniques that have been used in the outside world, so you need to be potentially prepared to deal with any of them when you're given some encrypted data. Now just to go through the different cipher modes. Electronic codebook is the least secure. The reason it's the least secure is that you can see from there that every block is encrypted individually, and there's no if you have the same data in 2 blocks, there's no difference in the output ciphertext. What is generating is always going to be the same. So there is the potential for someone trying to break this, seeing patterns in the data and possibly using that as a means of trying to figure things out. So basically in this mode each block is just encrypted using the key, and it requires padding. We have cipher block chaining. This requires an initialization vector. And what happens is the initialization vector and the plain text are combined with an XOR, and then they are passed with the key into the encryption algorithm. And then the ciphertext that's generated from that for that first block is then fed in as the equivalent to the initialization vector in the next block, and so on. So as you can see, each little block of data that's encrypted there is encrypted with a different initialization vector value, or a different value in the place of initialization vector, which means you're going to get a more secure encryption. It does mean that if you have any problem with your data, so there's an error somewhere through the data, it's then going to make it impossible to decrypt any data after the data with the problem, but hopefully you've got a secure way of storing and shifting your data. And then the other mode is counter mode. This requires an initialization vector, although when you read documentation about counter mode, it'll be called a nonce, which is a number used once. And this doesn't require padding because of the way it actually works. But you'll see in this case, the nonce is incremented for each block that's encrypted, and then it's fed with the key into the encryption algorithm, and then XORed with the plain text to generate the ciphertext. So anyway, these are 3 different ways that data can be encrypted, and as I say, if you're encrypting yourself, you're better, as long as whoever's going to decrypt it supports counter or cipher block CBC mode, you're better using those than ECB. But ECB is there in case you've been given some data from someone else which is encoded using that cipher mode. So when you're using the worker, it's like most of the other workers really. You have an object or object reference variable with OW3 crypto as the subtype, and you call init to provide input parameters, and then call $run to run it synchronously, or $start to run it asynchronously in a separate thread. And you receive the results through a callback $completed. There is another static method in the crypto worker, $makerandom. You can use this to generate some random data of a specified length, which is I bytes. And you'll need that if you want to generate an encryption key, potentially, or for generating an initialization vector. And this uses the random number generator, or the random data generator that's in embed TLS, so it's a reasonably random bit of data. We just looked now at running $init. Got quite a number of parameters, but most of those are fairly self-explanatory. You've got the action, whether you're encrypting or decrypting, what type of encryption, what cipher mode, and what type of padding. The key, now the size of the key depends on the encryption algorithm that you're using. You can see the different sizes we support there. And the initialization vector, if that's required as well. You can see the size required of that. Now the input data that you're going to encrypt or decrypt, you can either specify binary input data to encrypt or decrypt that data directly, or you can specify a character path name of a file, and in that case we'll encrypt or decrypt the data contained in that file without reading the whole file into memory. It will be done piecemeal as necessary, so it's a more efficient way of dealing, especially with large files. Similarly, you can specify an output path to actually write your encrypted or decrypted data directly to a file, which again is good for large amounts of data. Alternatively, you can output the data that you've encrypted or decrypted to just binary. And when the worker finishes, you'll get a call to $completed. And this is part of a row variable with 3 columns. One of these columns is data. So if you're not using the separate output file, you'll have a data column in the row variable, which is the encrypted or decrypted data, assuming the request was successful. Otherwise, there's 2 other columns which give you information about success or failure of the operation. So you have error code, which is 0 for success, non-zero for an error of some sort, and then if there was an error, error info will contain some information about the error. Now, if you're using cipher block chaining mode, you can use what's called an explicit IV. And what this allows you to do is encrypt and decrypt data without actually having to specify an IV, or in the case of decrypting it, without actually having to know the IV. And this is just a feature of the way CBC works. Basically, it will add a random IV to the start of the data when encrypting, and then when decrypting, we can remove the first IV size bytes of decrypted data from the start of the decrypted data. This is a technique that they use, I think, in TLS to avoid having to ship these random strings around. But like I say, this only works with CBC. No, I'm not going to delve into any great examples or demos of encryption because it doesn't really show you very much other than some data that looks a bit strange. But there is a sample in the hub, Crypto OW3 Worker. And if you take a look at this example in your own time, basically it will allow you to set up all the different parameters and different types of encryption, key size, IV size, etc. And then just hit start and it will execute that particular request, so you can decrypt or encrypt data, have a look at that and see what's behind there. It is all fairly straightforward. So now I'm going to talk about hashing. So what this will allow you to do, the hash worker, is asynchronously generate a hash value for some data. So you can use it for hashing passwords, or for a means of checking data integrity, or generating some sort of digital signature for some data. We support, for password hashing, PBKDF2, which is a very commonly used password hashing algorithm. It's in RFC 2898. The three secure hash algorithms and write message digest. And the reason we've chosen these ones are either because they're common and they're well used, but also because most of the support for these is in embed TLS. So again, it was something that we built on that because that was in OW3 already. So PBKDF2, as I say, you use that to securely store passwords, and what you'll do is you'll generate the hash, and then you'll store the hash in your database rather than storing the password itself. And when we generate the hash, we combine some random data called a salt with the password and generate the hash from that, and the actual encoded hash that we generate will include the salt as part of the encoded data that we generate to enable us to later verify the hash. And one reason for using the salt is it then means that two users with the same password will have a different hash. So there's another way of making it harder for people to guess passwords or decode.
So you would have different salt values?
Yes, there's a different salt. Yeah, different salt
take
values.
the username as a salt.
You take the salt and the user and the password and hash that.
Yeah.
And there, because you're using two different salt values, you'll have two different hashes. SHA and write message digest. These will just basically used to be for generating signatures with a limited probability of collisions. Hopefully very limited. There are some cases, but generally they're very good. So, to use the worker, this is similar to the other workers, as all workers are very similar, except you've got two different methods here. You've got $init hash to initialize the worker to generate a hash, and $init verify hash, which initializes the worker to verify a hash and say if it's okay or not. So we'll look at init hash first. So this takes three parameters: the data to hash. This is either a binary or a character value. If it's a binary value, the worker will just use that directly. If it's a character value, then, well, there's two different cases here. It's PBKDF2, because that's a password hash. We'll take character data and convert that to UTF-8 before we use it to generate the hash. But if it's for the other hash types, the character data must be the path name of the file containing the data you want to hash. So if it's a large file with a lot of data in, you're better supplying that path name than reading it into a binary and doing it directly in memory. The hash type is a constant. And then the final parameter, unless you're using pbkdf2, it's an empty row. But for pbkdf2, it is a row which has 3 columns, which are integers, which configure how the pbkdf2 hash is going to work. So you need to specify the length of the salt. Obviously longer is better, but longer may also mean that generating the hash will take longer as well, so generally 16 is not a bad value for the salt. The length of the key to generate, excuse me, and number of iterations of the pbkdf2 algorithm to use when generating the hash. And it seems, well, from what I can find looking online, that 100,000 is a good number for this. It'll take a second or two to generate the hash, but the larger value you use, the more secure the hash is considered to be. So after the hash has been generated, as it's a worker, $completed will be called, and you'll get a row with 3 columns, data, which is the binary hash, and then error code and error info. Now, if you have a hash and you want to verify it against some data, we have a different method here, $init verify hash. So you'll pass in the data for which the hash is to be verified, and just like this works just in the same way as the data parameter to $init hash, so it's either character or binary. This pbkdf2 character will be converted to UTF-8. If it's not pbkdf2, character will be the path name of the file with the data containing that you want to verify against the hash. The hash type, and then the hash that has been previously generated that you want to verify against the data. And you can either specify a binary hash, binary value, or you can specify a character string. In the case of a character string, it must be the base 64 representation of the binary hash. So, and in this case, $completed, after the worker has verified the data against the hash, you'll get an error code in the row parameter, which will be 0 if the hash was successfully verified. If it failed verification, I can't remember what the error code is, but there's an error code to indicate that. And if there's an error, some information about the error. And we have there is another sample in the hub, which again I'm not going to do much with. Where basically you can fill in these pieces of information and press test, and what will happen is it will, if you look behind the code, what's going on inside this library, the worker will be used to generate the hash, and then as soon as the hash has been generated, it makes another call to verify it. So it's showing you both sides of the interface. So it's, as I say, this is in the hub. Okay. This morning I had one request for MD5 and another request for HMAC type hashing, which I think I can probably provide both. I'll need to look at that in a little bit more detail because Embed TLS certainly has some support for HMAC, which I haven't included. So, is there any other questions? Or any?
Yeah, concerning MD5, so we use MD5 a lot, and we found that we run into problems. We did some externals on our own with algorithms we found and incorporated them into an DLL. But the problem was the file size, which we often do in additional MD5. And keep in mind that there might be a problem if the file's too big. More than 10 megabytes or so, then some algorithms crash. So please keep in mind, if you think you will do this, then you can write MD5 codes for big files.
Okay.
That's important. And another question, we often use encryption on the client side, in the JavaScript client, but I guess there's no support right now.
No, this is all server side stuff.
And we found some algorithms on JavaScript, and so it's working for us right now. Maybe
it's not something I've looked at, but I mean, I guess there must be
JavaScript
libraries.
We found some solution now, but especially if we would like to create some kind of client-to-client encryption, then we need encryption on the client side. And there's no support right now.
Okay.